In 1875, a geologist named William Denton was working at a tar quarry in what is now the middle of Los Angeles. He pulled a tooth out of the black asphalt, long, curved, serrated along one edge like a blade. He logged it as an unknown carnivore and moved on. He had no idea that tooth came from a site that had been silently collecting the dead for 50,000 years. Layer by layer, an entire Ice Age ecosystem had sunk into the ground beneath what would become one of the world's largest cities. The bones were still down there, all of them. When excavations began in 1901, scientists started pulling out bones by the thousands. Of one animal alone, more than 3,000 individuals have been recovered from a single site. The animal they belonged to weighed as much as a male brown bear, had canine teeth longer than your hand, and had been the apex predator of this continent for longer than our entire genus has existed. Almost nobody knows its actual name. The animal most people call the saber-toothed tiger was not a tiger, not even close. Its name comes from the Greek for knife and tooth. Its name is Smilodon. It belongs to a completely extinct branch of the cat family with no living members anywhere on Earth. And this is its story. Smilodon is a cat. Technically, it belongs to the family Felidae, the same family as lions, tigers, and the cat currently ignoring you from the sofa. But it did not belong to the same subfamily as any of those animals. It was a member of Machairodontinae, a completely extinct group of felids defined by their elongated upper canine teeth. The Machairodonts first appear in the fossil record around 15 to 16 million years ago and eventually spread across Europe, Asia, Africa, and both Americas. No living cat on Earth today is their direct descendant. When Smilodon went, the entire branch of the family tree went with it. The genus contained 3 species, and understanding the difference between them matters. Smilodon gracilis was the earliest and smallest, roughly jaguar-sized, living from 2.5 million years ago until about 500,000 years ago. Smilodon fatalis is the one everyone means when they say saber-toothed cat, the La Brea animal, ranging across North and South America from 1.6 million years ago until around 10,000 years ago. Then there was Smilodon populator, the South American giant, the largest of the 3 by a wide margin, and almost certainly the last to die, with some populations possibly clinging on well into the early Holocene. These were not the same animal at different sizes. Each one was shaped by a different continent, a different prey community, and millions of years of separate evolution. The first formal description of Smilodon was published in 1842 by a Danish naturalist named Peter Wilhelm Lund, working in limestone cave systems near Lagoa Santa in Brazil. He was working from fragments, not a complete specimen, and he still correctly identified something entirely new and gave it a name that has stood for 183 years. When large-scale excavations began at the Rancho La Brea tar pits in Los Angeles in 1913, the scale of what Smilodon fatalis was became overwhelming. Complete skulls, articulated skeletons, tens of thousands of individual bones from animals of every age. Scientists could suddenly study thousands of individuals at once. The Page Museum, opened on the La Brea site in 1977, now holds the single largest collection of Smilodon fossils anywhere on Earth. To understand the timescale Smilodon operated on, consider this. The oldest stone tools we know of were made roughly 3.3 million years ago. Smilodon gracilis was already hunting when those tools were being knapped. The first settled farming villages appeared in the Middle East around 10,000 years ago. The last Smilodon populations in South America disappeared at almost exactly the same time. Smilodon did not vanish in some unimaginably remote past. Its final chapter overlapped with the opening chapter of human civilization. People were learning to farm wheat in Syria while the last saber-toothed cats were dying in South America. That is not ancient history. That is practically recent. And it raises the question we will come back to. What exactly ended them? Every reconstruction you have ever seen of Smilodon is part science and part educated guess. The more photorealistic and confident it looks, the more skeptical you should be. What the fossil record preserves is bones, and La Brea has produced thousands of them, covering every part of the skeleton. The bones are well understood, but muscle mass, coat color, stripe or spot patterns, ear shape, none of those fossilize. Some things can be estimated from bone surface detail. Others require an honest admission that no one knows. The images you grew up with were someone's best guess, and some of those guesses were not good. The biggest species, Smilodon populator, stood 1.2 meters at the shoulder, reached about 2.1 meters in body length, and weighed in large individuals somewhere between 300 and 430 kilograms. One skull from Uruguay suggests an animal approaching the mass of a large polar bear. The most familiar species, S. fatalis, was smaller but still heavier than any living lion, with a stocky, forward, heavy build, a thick, muscular neck, short hind legs, and a stubby, bobbed tail. Nothing about the hind limb anatomy suggests an animal built to run prey down. Everything about the front half suggests an animal built to close a gap fast and hold on. The teeth are the reason this animal has been famous for 150 years. Each upper canine in S. fatalis measured roughly 17 to 19 centimeters. In S. populator, the canines reached up to 28 centimeters, longer than most people's forearms from wrist to elbow. These were not round like a lion's fangs. They were flat, narrow, and curved, shaped more like a carving knife than a spike, with fine serrations along both edges. Those serrations reduced the force needed to cut through tissue the same way a serrated kitchen knife does. A smooth blade pushes, a serrated blade slices. Here is what most people find genuinely surprising. Those enormous teeth did not come with an enormous bite. Smilodon's bite force was actually lower than that of a comparably sized modern lion. The jaw opened to roughly 90 to 95 degrees, nearly twice the gape of a modern big cat, because the long canines demanded it. But at that angle, the muscles could not clamp with the same force. The sabers were not for crushing. They were for slicing, at exactly the right moment, into exactly the right place. Power was not the point. Precision was. The forelimbs completed the system. The attachment scars on Smilodon's shoulder and chest bones indicate pectorals, deltoids, and biceps that were enormous by any Felid standard. Biomechanical studies conclude that Smilodon did not simply lunge and bite. It first seized prey with the forelimbs, pinned it under its own body weight, and only then drove the canines in. This sequence was mandatory, not optional. The long, flat teeth were strong along the biting axis, but brittle under sideways force. Any prey animal twisting hard against the embedded canines risked snapping them. The forelimbs had one job: eliminate that lateral movement before the teeth went in. The canines were the killing instrument. The forelimbs were what made it safe to use them. One last thing the bones make clear: Smilodon was not a fast runner. Short hind legs, heavy forelimb mass, a stubby bobbed tail, almost none of the features that make modern fast cats fast. Its strategy was almost certainly built around cover and ambush. Close the distance in a short, explosive charge, seize the prey before it can react, bring it down before it escapes. The tooth-wear evidence from microscopy work on hundreds of La Brea specimens supports this directly. The wear patterns look like a woodland or scrub predator, not an open country pursuit hunter. The North America that Smilodon hunted across looked nothing like the North America of today. In terms of large animal diversity, it was closer to the modern African savanna than to anything currently living on that continent. Horses ran wild across the plains, camels browsed the scrubland, woolly mammoths and mastodons moved in herds. Giant ground sloths, some of them the size of small elephants, tore up vegetation with claws the size of bananas. Ancient bison with horn spans of 2 meters grazed the grasslands in enormous numbers. Southern California around La Brea, 15,000 to 20,000 years ago, was cooler and wetter, a mosaic of savanna, wetland, oak woodland, and pine forest. What Smilodon actually ate is something scientists can now read from its bones. Stable isotope analysis shows a heavy reliance on large terrestrial prey, with horses and bison coming up most consistently. Smilodon did not hunt in a vacuum. The La Brea assemblage shows it sharing territory with the American lion, which was larger than any living lion species, with the short-faced bear, the most powerful land carnivore in North America at the time, and with packs of dire wolves competing for the same carcasses. How these animals divided the available prey, which species dominated a fresh kill, and which waited, is something the fossil record can only hint at. What it does confirm is that all of them coexisted in the same landscape for thousands of years. Smilodon was apex, but it was apex in a world that pushed back, and when that world collapsed, none of them were prepared for it. The most remarkable evidence from La Brea comes from the Smilodon bones themselves. Multiple specimens show injuries that had fully healed before the animal died, injuries that would have been completely incapacitating during recovery. One individual had a fully healed pelvis dislocation, another had a healed femur fracture. A broken femur makes normal locomotion impossible for weeks, sometimes months. An animal in that condition cannot hunt or find food without help. Both of these individuals survived long enough for bone to grow back solidly across the injury site. That kind of recovery does not happen in a solitary predator living alone. The evidence for sociality is debated, but what it confirms is that individual Smilodon were sometimes dependent on other Smilodon for survival. Whatever you call that arrangement, it is not living alone. Between approximately 13,000 and 10,000 years ago, the large animal communities of the Americas collapsed. In North America alone, at least 37 genera of megafauna disappeared, representing roughly 80% of the continent's large mammal diversity. The losses were not random. Small mammals largely survived. Birds came through far better than mammals. What disappeared was almost exclusively the large and very large, slow to reproduce, requiring large territories, taking years to reach breeding age. This was a systemic failure that targeted the biggest animals with frightening precision. At La Brea, the youngest reliably dated S. fatalis fossils come from approximately 11,000 to 12,000 years ago. In South America, S. populator held on longer, with the youngest confirmed dates around 8,000 years before present. The first copper tools in Europe were already being made by then. Smilodon's extinction happened inside human history, in a world where people were already building things that lasted. What caused this collapse is one of the most argued questions in all of paleontology. The climate case, the end of the last glacial period around 11,700 years ago, was not a gradual warming. Temperatures shifted significantly within human lifetimes. The vast grasslands that had supported the megafaunal herds contracted and fragmented as forests expanded into former grazing land. The great herds were grassland animals. When the habitat broke apart into islands, the populations did too. The human overkill hypothesis argues that timing alone implicates us. Paleo-Indian hunters arrived in North America around 13,000 years ago and encountered prey animals that had never seen a human before and had no evolved instinct to flee from one. A bison that does not run from a person with a spear is an easy target. The extinction timing in different regions of the Americas does follow human arrival with uncomfortable consistency. The most credible current view is that both causes were real and reinforced each other. Climate stress weakened the system, human hunting tipped it over the edge. Neither cause alone is sufficient. Together, they were enough. Why did Smilodon specifically fail when wolves, pumas, and jaguars survived? Specialization. Smilodon was built for one thing, taking down large, slow-moving mega-herbivores using four-limb restraint and a precision canine bite. That technique does not scale down. It does not work on deer. A puma shifts to deer when the horses disappear. A wolf scavenges. Smilodon had no equivalent flexibility. Its body was an optimized system for prey that was vanishing, and at 250 kilograms, it needed a lot of that prey just to survive. When the mega herbivores went, there was no plan B. There was only the end. The very last Smilodon individuals on Earth were probably a small, isolated population somewhere in southern South America, living in a world that bore almost no resemblance to the one their genus had dominated for 2.5 million years. The horses and camels that had once moved in herds across the pampas were gone. What remained were smaller, faster animals that a saber-tooth ambush predator built for giants could not live on in sufficient numbers. At some point, the mathematics became terminal. The last litter that produced no survivors. The last adult whose death went unreplaced. And then, the silence that has lasted 8,000 years and counting. The ecological role Smilodon played was never filled. Pumas expanded their range after the collapse and became the dominant large felid in North America, a position they still hold today. Wolves increased, jaguars retreated south, but none of these animals replaced Smilodon in any meaningful sense. None of them are built to take down prey the size of Toxodon or a fully grown mammoth. The niche of the large ambush megafauna specialist has been functionally empty in the Americas for 10,000 years. Meanwhile, the research keeps coming. A 2025 study in the Anatomical Record compared the skull mechanics of Smilodon fatalis with other saber-tooth lineages and found that the killing bite was not a single universal technique. Different lineages had evolved meaningfully different approaches to the same basic problem. The fossils that William Denton puzzled over in 1875 are still producing first-rate science 150 years later. Smilodon matters beyond its own story. It is a case study in what happens when a highly specialized organism meets a world that changes faster than evolution can track. It survived roughly 20 glacial cycles and 2.5 million years of shifting climates and shifting prey. Then, in the space of a few thousand years, it was gone. Smilodon is one of those animals that earns your respect more, not less, the closer you look. Behind those famous teeth is a 2.5 million year success story that ended not because the animal failed, but because the world it was perfectly built for stopped existing. That combination of absolute competence and total fragility is what makes it, for me, one of the most compelling animals in the entire fossil record. If this episode left you with questions, put them in the comments. If you found this useful, like helps the channel, and subscribing means you will see the next one when it comes out. And until then, stay curious. Thanks for watching, watch this video next, and subscribe for more.